In the colorful Amazon rainforest, a fascinating event happened where a massive crocodile and a formidable electric eel engaged in an intense face-off. Since crocodiles are known as some of the best hunters in the animal world, they usually don't back down from a hunt. But this time, a crocodile found itself in a different situation. At first glance, the electric eel may seem like an easy target, but it possesses a potent secret weapon that proves nearly unbeatable even against the mightiest marine adversaries. As the crocodile attempted to strike, the eel unleashed a jolt of electric energy. This wasn't just any shock. Its intensity both surprised and confused the crocodile. The sudden surge of electricity caused the crocodile to convulse uncontrollably as it coursed through its body. Tragically, the encounter ended with the crocodile's demise as its muscles spasmed wildly until its heart eventually stopped beating. The once dominant crocodile learned a shocking lesson. Underestimating the electric eel could indeed lead to fatal consequences. Now, as we take things further to observe the broader context of the electric eel's existence, we'll find that these creatures offer a captivating glimpse into the ongoing process of evolution. The electric eel exemplifies a remarkable adaptation within the fish kingdom, characterized by their elongated bodies and ability to generate electric fields. Within this group are not only electric eels, but also other notable members like the banded knifefish and the glass knifefish. However, electric eels stand out as the undisputed champions in the world of generating bioelectricity in this family. A big discovery in 2019 showed us there are actually 3 different types of electric eels in the Electrophorus genus: E. electricus, E. volti, and E. veri, with E. volti being able to generate the strongest electric shock of up to a staggering 860 volts. While electric eels are champions of the electricity production, they share their home with the other gymnoformes fish. Many of these fellow inhabitants use their electric abilities for navigation or communication purposes, rather than for defense or hunting prey. Electric eels, with their extraordinary ability to emit substantial electric shocks, serve as a striking example of nature's ingenuity in defense mechanisms. This ability functions as a potent tool for self-preservation, posing a deadly threat to predators, including formidable adversaries like crocodiles. The shocks emitted by electric eels are complex biological tools capable of hijacking the nervous system of their targets. The intensity of these shocks can induce severe muscle spasms and paralysis, or even death if the affected creature can't recover quickly. The story gets even more interesting with discoveries by scientists like Kenneth Catania from Vanderbilt University. He has observed electric eels jumping out of the water to hit their targets with more powerful shocks. This tactic goes beyond mere display. It represents a clever strategy employed by electric eels to maximize the potency of their electric assault. By making direct contact in the air, electric eels can bypass the water, which would otherwise reduce the shock's impact, thereby guaranteeing a more potent delivery of their shock to any nearby threat, such as the ill-fated crocodile that ventured too close. Looking closer at what makes electric eels so electrifying, we find that they have specialized organs filled with cells known as electrolytes. These cells are capable of creating electric charges through the movement of sodium and potassium ions, a process initiated by the eel's nervous system. An incredible 80% of the electric eel's body is dedicated to making electricity. It has 3 pairs of electric organs: the sacs, hunters, and main organs. The main and hunters organs are used for defense and hunting, producing high-voltage shocks, while the sacs organ, emitting low-voltage pulses, helps in navigation and communication. Inside these organs, there are hundreds of thousands of electrolytes arranged neatly, ready to release electricity. When the eel's nervous system sends a signal, it causes ions to move, creating an electric charge. This well-organized process lets the eel release a strong electric shock to defend itself or catch prey. Drawing from the electric eel's mechanism for generating electricity, researchers have created soft batteries and hydrogels that could revolutionize the power sources for soft robotics, wearable tech, and even medical devices, showcasing a beautiful blend of nature's ingenuity and human innovation. This ability to send out electric shocks is essential for them to navigate, hunt, and protect themselves. Think of electric eels swimming in dark waters, using electricity almost like a radar to see around them. This electric sense lets them spot their next meal or any threats that may be hiding. When they hunt, they're both clever and practical. They start by sending a signal that opens an ion channel on the connected side of the electrocyte, letting positive ions back in. The other side keeps pushing positive ions out, making one side of the cell positively charged and the other side negatively charged. This creates a dipole, or two opposite charges, allowing the eel to produce electric shocks. The electric current moves toward the eel's head, which is positively charged, and releases through the water to strike at prey or defend itself. The more these cells are aligned and stacked, the stronger the electric shock the eel can create. Interestingly, the eel can open all its cell gates at the same time, leading to a powerful electric burst. This might sound extraordinary, but it's just an advanced version of what regular muscles and nerve cells do. These cells let the electric eel create shocks that can reach up to 600 volts, strong enough to fend off or even stun much bigger predators. There have been times when electric eels have jumped out of the water to deliver a concentrated shock to large animals, like caimans. This not only shows how effective their defense is, but also highlights the evolutionary benefits of their shocking abilities, allowing them to face and scare off big threats. Delving further into how electric eels use their shock power uncovers some fascinating behaviors. For instance, biologist Kenneth Catania from Vanderbilt University decided to see how strong an electric eel shock really is by letting a small one, about 16 inches long, shock his arm. The shock he felt was similar to touching an electric fence, showing just how powerful and useful these shocks can be for the eel, whether to keep predators away or to catch prey. The story of electric eels took an even more fascinating turn with a discovery by researchers at Nagoya University. They proposed that electric eel shocks might even transfer genetic materials between species, suggesting effects that extend beyond just the zap itself. This idea opens up exciting new avenues for exploring how electric eels might influence the genetic makeup and ecological dynamics of their surroundings, indicating a more complex relationship between these creatures and their environment. In areas where electric eels are found, local communities have developed a respectful cohabitation with these powerful creatures. Local fishermen who know the stories of these waters well navigate their boats with a respect that comes from deep understanding. They don't see the electric eel as an enemy, but as an essential part of the water's intricate web of life. Electric eels, known for their powerful defense mechanism, rarely end up in the fishermen's nets. Their bodies, lean and full of bones, aren't sought after for food. But it's not just the fear of an electric shock that keeps the fishermen at bay. It's their respect for the eel's place in the balance of the ecosystem. Electric eels feed on fish, amphibians, and crustaceans, acting as guardians of their environment. Their hunting helps to keep these populations in check, ensuring the health of their aquatic home. Apart from their role in the ecosystem, electric eels are the undisputed rulers of their world, with no natural predators except the boldest humans. Their ability to emit powerful electric shocks keeps potential threats away, earning them a place of respect in the natural order. This unique talent, along with their method of using electricity to catch prey, shows the special role electric eels play in the life of South American rivers. For those eager to encounter these fascinating creatures, a journey into their habitat reveals more about their lives. These fish live in the fresh waters running through the neotropic areas, adapting to a wide range of environments. Electric eels are mostly night creatures, spending their days hidden in river mud or swampy areas and coming out at night to hunt, often preying on fish, sometimes even those within their own electric community. This group of fish is essential to their ecosystem, acting both as hunters and as prey. They also show some pretty cool adaptations, like the way they move. They swim by waving a long fin along their underside, a method that shows off their ability to survive and thrive in the water. To effectively protect these incredible electric eels, we need to gain a deep understanding of their behavior, communication, and social structure. Preserving both the eels and their river habitats is highly essential to ensure their long-term survival. By undertaking this endeavor, we contribute to ensuring that future generations can also marvel at these incredible wonders of nature.